AI functions in Databricks SQL let you apply foundation models to your data, all in SQL. No need for separate pipelines, jumping between programming languages, dealing with API orchestration, API keys from multiple providers, different usage limits. So you can start using language models for tasks requiring semantic understanding without leaving SQL. With this functionality, you can do batch inference at scale with the same governance, permissions, and observability as any other SQL query in Databricks. And on top of that, you're not locked into using one particular model. Databricks now provides native access to top models from OpenAI, Anthropic, Google, and Meta. Using them in SQL is as simple as changing out one parameter in the AI query function. This is important because there is no one-size-fits-all model. The ability to use any model means that you can always choose the best model for the job. Now let's see it in action. Suppose we have a collection of customer reviews from a restaurant delivery service that we want to work with in Databricks SQL. Maybe we want to generate simple summaries of these reviews, or maybe we want to convert them into structured data for use in some downstream application. Let's first define a simple data set of 5 different reviews. We will include the order ID, the text of a review, the amount of time that the delivery took, and the actual items that were ordered. These 5 reviews include both negative and positive reviews. So let's set up this table. We will start with a very simple use case. We are simply going to pass the review text in and ask the language model to summarize it. We're going to use the AI query SQL function. In this simple use case, we only need to pass in 2 arguments, the model that we want to use, and then the prompt. So we will start by trying out the Gemini 2.5 Flash model from Google, and we will include the prompt, summarize this customer review in one short sentence, to which we will concatenate the review text. Let's run this and see what it looks like. And we can see that we get out of this the original review text and the shortened summary for all 5 of the reviews. Now, it is extremely easy to swap the model that we used to power the AI query call. Let's see this in action. Instead of using Gemini 2.5 Flash, let's use the Meta Llama 4 Maverick model. All we have to do is change the model parameter, and there we go. We end up with the same data set with summaries generated by a different model. And you can use any foundation model for this use case because, like I said at the beginning, you should always be able to use the best model for the job. Instead of plain text output, you might actually want to turn the reviews into some form of structured data on their own that can be used by some downstream application. You can also do this with the AI query function. Let's see what that looks like. So this starts out very similar to what we did before. We have the AI query function. We pass in the model that we want to use, and we pass in a prompt. In this case, we have a slightly more involved prompt, but only because we pass in some of those other details like the delivery time and the items. But additionally, we pass in this response format parameter, which defines what we want the output to look like. There are a few different approaches that we can take to this, but in this case, we're using the JSON schema approach. So what we're asking for is a JSON schema with a selection of particular fields, including the order ID, which can be extracted from the prompt, a classification of the type of review, the severity of the concern if it is a negative sentiment issue, the customer sentiment, which might be positive, neutral, frustrated, angry, any suggested actions, and the rationale for those suggested actions. Let's run this with the Claude Sonnet 4.5 model and see what it looks like. You can see that whereas before we received text as the output, now we have this formatted JSON with all of the fields that we asked for. And just like before, you can switch models as easily as changing the first model parameter. So let's try this with GPT-5 Nano. We'll run it again. And once again, we see that we have JSON output following the schema that we set. To get the right balance of cost, latency, and task-specific performance, we probably need to compare a few different models. We can also do this right in SQL. The only difference between this query and the previous one is that we will declare the review schema variable just so that we don't need to rewrite it multiple different times for each comparison. And then we will run the AI query function for each model that we want to compare with the same prompt, passing the review schema variable that we defined above as the response format. And we will end up with a separate column for each of these different model responses that we can compare very easily, either manually by reviewing ourselves or by passing those results to some kind of downstream comparison tool. And as you can see, we end up with separate columns for each of the providers that we used. And even without reading them in detail, we can see that there are some differences in the relative length and some of the formatting that might ultimately affect how we use them in some downstream application. In this demo, we have seen how easy it is to use foundation models from all of the major model families from OpenAI, Anthropic, Google, and Meta, and more, right in SQL using the AI query function. You can swap between them by changing just a single parameter, test out different models in terms of speed and latency versus performance, no API keys, no authentication sprawl, unified governance across every model. When you need the best model for the job, you can actually choose it, switch to it, test out different choices without rewriting your code, without using different SDKs, juggling between different provider requirements. It's all right in your Databricks workspace. Give it a try today. You can get started right in the SQL editor.